Evening, everybody. I thought I'd do a little bit more on the truck tonight. So I've disconnected a load of wires already. The rear drive's out. Circuit board just removed. It was just 1, 2, 3 screws there, just down through this. So this is going onto the junk pile eventually. I'll probably need to keep this little stand here for the light further down the line. So that goes over there. So I thought what I'd do is actually have a look at the steering mechanism. It's pretty close to it being a servo from what I can tell. There's 4 screws normally, 1, 2, 3, 4, and then there's also these 2 screws here. It's quite a clever design they have. It's got quite a few sort of standard safety sort of features that you would see in these things. There's a sort of servo saver built into it. So I'll just pop this off here. So this is the unit itself. Small motor, worm and wheel drive, going through a reduction to this gear here. And then this drives this gear here, and there is a small spring just underneath. So small spring just in here. And then there's a metal bush on the top here, and it comes down to a drive gear here, which would go onto the sort of steering gear, which I'd already taken off before because I've been having a little look. So that would go onto that, and this has a pin on it which drops into our steering rack. I'll leave that off for the minute. So this actually here, the reason why it's got this small spring is it's actually a clutch. So this can free spin, so that if you max out on your steering travel, this motor can sort of keep spinning, and it's just going to slip on this clutch here. So the system actually has built into it, this has got a spring on either side. This is a form of servo saver. It's very stiff, very stiff. Now I do remember you couldn't do what you term dry steering with this. It would only steer when you were travelling backwards and forwards, so you couldn't turn the wheels from lock to lock in a stationary position. You had to be travelling. So I would like to be able to dry steer. My intention is to go to a standard size servo. So maybe I'll look at something to improve, reduce the friction on this, to make this a little bit easier for that to happen. The way that this drives is this little gear here has a peg on it which drops into there, and then when that's driven, that travels from one side to the other. And the steering stops actually are set up by the centerpiece here hitting one side or the other like that. So it's just catching on these little mouldings on either side here. So that can move backwards and forwards and like that. So I've been having a look at this, and these top sections here, they're going to need to be retained in some way because they are effectively the top of the kingpin here. So that'd be the kingpin. So that's the top of that. Some people may call them wishbones, various names. The centre section can be got rid of. Now, what I've actually discovered is, pull that gear off there. This actually, if that's lined up with that there, if you put those two in place there, the servo seems to actually line up with this section here. And just doing a little bit of a measurement, if I do a measurement between the hole centres on this, it comes in at sort of 49 millimetres, and then if I do the same on a servo, that's nicely sort of the same at about 49 millimetres. So I'm pretty certain what I'm going to be able to do is remove the top section of this, and then mount this through here. I would like to have been able to use the original gear to drive on, but unfortunately the centering there is not going to fit onto the drive for from the standard servo. So I just had a gear. I've had a little bit of a mess with this. I've managed to measure the distance that this travels, so the gap between this point here and this point here, it's about 8.5 millimeters, 8.75. A little bit of maths and calculating, working out with the standard servo, because the controller I've been looking at, it's got no steering limits. You can't, reduce how much travel steering will do. So it's always going to go to full travel, which is 120 degrees on this servo. So I've had to do a little bit of calculating, and I've banged a screw in there. It's just slightly closer in than that peg is on that, because this will travel slightly further than that did to get the distance of movement. So the idea is that would drop in. It's a bit of a shame that everything's black on this. I might look for something a bit better than this screw. I do have a few of these little black bits. So that would drop into there, and then the servo, when it drives, will drive that each way. And I'm fairly certain that if I can remove all these gears from here, that motor, this upper section from here, that I'll be able to get the servo drive to locate down through the centre of there. It appears to be pretty much in line with that, maybe fractionally out with the mountings on here in the servo, but we'll see. And then if I get the distance right, I think it'd just be a case of some blocks to run across from here and here that this servo can drop into, and then I could screw down through the servo into the blocks across there. I need to get down to the garage to be able to extract this pin from here, because these gears, this brass bush, I presume it's going to be brass, and this gear here, they're actually pressed on from either side, and I can't disassemble this gearbox without getting these off. So that's going to be after something that when I can nip down to the garage and have a look. So I'm fairly confident with that, having explored it, that I should be able to build this up with a standard servo mounted something like that at the front end, and that'll give us the steering lock that we want to be able to get off this. So yeah, it's the chassis stripped down quite a bit. I'll unsolder all these connections from here. I may as well use this switch. I'll just have to buzz out and find out which connections are connecting up as it does slide across. I imagine it's effectively two double pole, double throw switches, one here and one in this side here. I need to just double check that, and then I can work out which measurements which connections I would use for hooking everything up. And then I need to be looking at this. Now, I have had a look at various motors, and if I can work out how to do this, I am getting new to doing this whole streaming thing and doing webcams. One thing I think I do need is a better camera than I've got. I did buy this. It's just a standard webcam in, I think, 2007. It is a HD one, but I would like something of better quality. Yeah, I've had a look, and there seems to be some motors out there. I think they're by a company called Surpass, but they've got some good information, and the physical size, I think it's a 2040 or 2030, but I'm still finding out about this whole kV. I mean, kV to me is 1,000 volts, but they're talking revolutions per volt. So I've got to look at the gear ratios that would be available. That may be a way that I go for this, because the motors do seem to be small. You can get them, and they come with speed controllers for relatively cheaply, a lot cheaper than I would have imagined. that this kind of thing would come. So the £20 mark for a speed controller and a motor, from what I've seen. So I don't want to put a fortune into this thing. I've already spent more on it buying it than it cost me, my parents, back in 1979. But I do want to get this thing kind of up and running. And this needs to be going before I can get a sand scorcher. The sand scorcher will follow. And I will be doing I think before I do some more on this, I might do a review of the Barbie car that I built for my daughter, and throw that one up so you can have a look at that. I kind of wish I'd done a build video on that one, but I'll just be able to talk you through that one a little bit. But thanks for watching this time. Please do subscribe and have a look and see the other videos. It's a new channel. I'm trying. Thanks very much. See you. Bye.